The main thing I did was clean up the compiler code. There used to be 1,000 or maybe 800 lines of code that I got rid of that was in the back end of the compiler. So with the compiler back end, there's intermediate codes, which are basically the instructions that it makes intermediate code before it makes the final machine code. And on each of these, they can have one operand or two operands. And before I had it so that each of these implementations had to handle the first operand first and the second. They had to handle A, B, or B, A. The order could be inverted. Sometimes you pass the register in RAX, and when you're juggling the registers, it makes a difference if RAX is the first operand or the second operand. I'm talking about the intermediate code, not the final assembly. Anyway, so I cleaned up the compiler. It actually turned out to be it's actually less optimal now, but the code for the compiler is a lot better. It doesn't really make a difference on performance. Anyway, I de-optimized the compiler. That's what you might call it. Anyway, so I also, while I was working on that code, I changed on the back end. They used to have a type for. Let's take this as an example of a typical intermediate code. This is for an add, or, and. This is for all the operations that work like add. Subtract is different because it can be one first or the other first makes a difference. Anyway, I'm not explaining this very well. So the add takes that's an argument 1, argument 2, and argument 3. I think this one takes 1 and 2 and puts them in 3. I don't remember. Anyway, so each of these intermediate code arguments have a type, a register, and a displacement. And what I did is in the past I had a naked integer. And I replaced it with a type. The naked integer was kind of hard to understand. What it should be is a 16-bit type mode combination. And I went ahead and cleaned up the modes. It was a big mess. Anyway, so just for your information, there's these modes can be immediate, register, displacement, indexed, or RIP displacement. This is kind of the intermediate code is very, very close to x86 addressing modes, but not quite. Basically, what these functions do is they convert. The machine code has two different instructions for add, one for immediate and one for register, and this basically is an abstraction layer. When it calls this, it takes it from the abstract intermediate code to the less abstract machine code. Anyway, so I cleaned up the compiler a lot. I abbreviated integer as int. I've been doing that over the years, doing abbreviations. There's only a couple labels that were affected. I have a list of all my abbreviations. The reason I took so long to in my glossary here's all my abbreviations. I try to document them each time I do an abbreviation. They teach you not to use abbreviations, but I like them, so I use them, and I don't care what people say. But I do document them, and I try to stay consistent. So for a long time, I didn't want to use int as an abbreviation because there's interrupt and integer, and I was using it I was trying to keep it one abbreviation for one word, but in this case, there's both integer and there's interrupt. So there's a file in the compiler directory called opcodes, and what that is that's for the assembler. It's not for the compiler. The compiler doesn't use this, but the assembler uses this, and this has all the addressing modes for the opcodes. And what I just did, I get to choose the rules for how I count the 100,000 lines. I set a limit of 100,000 lines for Temple OS. I don't want to go over 100,000 lines. And when I set that limit, I decided this opcode file must be counted. And what I just did is I just added an alias feature. See how these, let's go to the jump. The jump instructions have alias. You can either say jump not equal or jump 0. And I used to have separate entries, but now I created an alias feature. And so it saves some lines of code, and it also makes the unassembler so it's not ambiguous. So it always uses the preferred opcode for the unassembler. So, here, this is kind of exciting. This is probably the most exciting thing on this new version, I guess. If you've ever looked at, if you've ever done forms, you'd have to be a hardcore. I don't think anybody in the whole world except me has done forms in Temple OS. Forms where you prompt for data. Well, there's a syntax for the doldoc commands prompting for data. And in the past, you had to say length equals 511 for a 512, and now it figures that out for you. So you don't need to put that in the. It figures that out from the compiler information. So that should make it really, really pleasant. That is so cool. I'm proud of that. So this is how you prompt for forms. Watch this. So we can do. Oh, it also figures out if it's float or integer. 4, 5, 6. Anyway, so to prompt for float, you just say this is the string. This is the kind of like the printf or scanf string that gets displayed, and then you have the DA stands for data. There's also a list widget and a checkbox with a bool. This will figure out if you have an 8-bit or 16-bit or 64-bit. It'll figure out and put the list result into that size. This is only for the doc form function. So in this doc form function, I check the compiler information for the member that's being formatted, and then I set. Well, what I did is I made a flag if it's supposed to use the default. Anyway, the way I implemented it is the $commands have a flag if it uses the default or not, and if it's the default, then it goes ahead and uses the compiler option. You can override it if you do say raw type. If you say raw type equals I8, then it would only put the result in an 8-bit. Anyway, so I don't think anybody else is doing any. I don't think anybody on Earth has written any programs for Temple OS, but if they did, they would be excited. So finally, I made a character graphics demo. It's actually Temple OS draws the font by hand. It's actually not text mode. And anyway, I'll just go ahead and show you this. This is what I did with my Commodore 64 in high school. This example uses smooth scrolling. It looks crappy with the flicker. It's not flickering. The borders kind of jostle back and forth. I don't know if I'm going to fix that. On the Commodore, what they did is they always had a column blank, and that's not so easy to do. If you don't look at the edges, it scrolls smoothly. But if you look at the edges, then it chops back and forth. So that example is kind of fun. The best part about character graphics is animations. You can make the waves all move. So there's no reason to do character graphics except for fun. I have some examples of this. Oops. If you look at the big guns, these graphics are it's bitmap, not character graphics. Anyway, so I'm just showing you some of the examples that don't use character graphics. The other one, Rawhide, doesn't use character graphics. So that you can look at those if you want to see how. There's no reason to use character graphics. Just do it the way I did with Rawhide. Anyway, so I think that's everything in the new version. I release every couple weeks. I release constantly as I work. I put it on my website. Yeah, as a matter of fact, there was a day when I had a bug uploaded. As it turns out, yeah, I feel bad about that. I think about 3 or 4 people downloaded it. A compiler bug. Oh well. So I release as I go, and I should say I put it on my website as I go. And then every couple weeks I do. If I've done something, I do a release so that I get some attention in the press. And then just anyway. So that's it.